Hello students, this is Giants Pro Zambia. So in today's video, we'll focus on atomic physics. So basically, atomic physics is the branch of physics that talks about the structure and composition of atoms. So we'll go on to look at the structure of atoms. Then in future videos, we'll also look at unstable nucleus of atoms and how they are able to decay. That's what atomic physics and radioactivity is all about. So let's begin. We'll start with the structure of atoms, atomic structure. What you need to know is that for matter to exist, for matter to be there, we must have small things that join up to come up with a large substance. So these small things, they join up. These are the building blocks. So when they join up, they form a large substance which we are calling matter. So these things, small things that join up, are the foundation. They are the building blocks of matter. Then these are what we're interested in. These are atoms. So atoms are simply building blocks of matter. Now we want to look at the structure of these atoms. So what you need to know about the structure of an atom is that an atom has two sections. It has the central part. This central part of an atom is something called the nucleus of that particular atom. So the central part of an atom, the center where its entire mass is distributed, where its entire mass is concentrated, that's the nucleus of an atom. Apart from that, an atom has what we call energy levels, or simply shells. So within these shells, there are some particles that orbit the nucleus, that move around the nucleus. So apart from knowing about the sections of an atom, that is the nucleus and the shells, you need to know about the subatomic particles that are found within an atom. So an atom has three subatomic particles. So these are the protons, the neutrons, and the electrons. So within an atom, we have three particles that are found in there. These are the protons, the neutrons, and the electrons. The protons and the neutrons, these are found in the nucleus. They are bound within the nucleus. They are fixed in this nucleus. A nucleus is just a central part, a small part of an atom, which is at the center, where its entire mass is concentrated. That's the nucleus. Then within that nucleus, that's where we find the protons and the neutrons. Then we also have some other particles, which are the electrons. These electrons are found within shells. They orbit the nucleus. So these orbit, they move around the nucleus. They orbit the nucleus. So electrons are free to move, whereas the protons and the neutrons are bound. They are fixed within a central part called the nucleus. But for electrons, these can move. They move around the nucleus. They have enough energy to move around the nucleus. But for electrons, for protons and neutrons, they are locked up in the nucleus. So what have we talked about? We've talked about an atom. Then we're saying this atom has two sections. It has what we call the nucleus. It also has something called the energy levels, the shells. Within the nucleus, we have two things that are found in the nucleus. We find protons there, we find neutrons there. Within the shells, there are things that move around the shells, and these are none other than the electrons. So these are the things that you need to look at when talk about the structure of an atom. You need to know that an atom has the central part called the nucleus. It has what surrounds the nucleus, the shells. It has the protons and the neutrons. These are found within the nucleus. Then around the nucleus, we have some particles that orbit it, which are the electrons. So you can have an atom there Let's say that is the central part. Within this part, we have the protons and the neutrons. Then surrounding the nucleus now are the shells where electrons are found. So that's an atom. Now, apart from that, you need to know something about the protons, the neutrons, and the electrons. So the protons basically have a mass of one unit, and they carry a positive charge. So protons carry a positive charge. The protons carry a positive charge, and they have the mass of 1. The electrons, these are particles that are found within energy levels. These have a negligible mass. It's close to 0. It's about 1,840. 1 over 1,840. So you can see 1 divided by this is something that it tends to be 0. So electrons have negligible mass. Then they have a negative charge. So electrons carry a negative charge, and they have a mass of 1 over 1840. The neutrons, so this is the mass of electrons. They have a mass of 1 over 1840, and they carry a negative charge. For neutrons, the neutrons are found in the nucleus together with the protons. These have a mass of 1, and they do not have any charge. They are neutral. The charge is 0. So these are the properties of the 3 subatomic particles: the protons, electrons, and neutrons. Protons have a mass of 1. They carry a positive charge. Electrons have a negligible mass, which is about 1 divided by 1,840, and they have a negative charge. Neutrons have a mass that is equal to the mass of protons, which is 1, and they are neutral. The charge is 0 here. Now, apart from that, we need to know something. We need to know something about atoms. We've said that an atom has the central part called the nucleus. Then we've said that within this nucleus, we have 2 subatomic particles that are found in the nucleus. These are the protons and the neutrons. Now, what you need to know is that the protons and the neutrons together are something called the nucleons. They are called nucleons simply because they are found in the nucleus. So nucleons is the collective name for protons and neutrons. So protons and neutrons collectively are called the nucleons. So we're saying nucleons. This is the collective name for protons and neutrons. So if I have this nucleus, then let's say we have these particles in there. I'll represent the protons by showing the positive charges there. Then I'll leave the neutrons uncharged. So this is the nucleus. Then the particles that are found in the nucleus are the protons and the neutrons. So I can count 1, 2, 3, 4. I have 4 protons there. 1, 2, 3. I have 3 neutrons there. So we can clearly see that we have 4 protons and 3 neutrons. Then I can also say, since I have 4 protons and 3 neutrons, collectively I can say I have 7 nucleons. So in other words, we are saying the protons and the neutrons together are called the nucleons. So I can have something called nucleon number. So when we talk about nucleon number, we're talking about the number of nucleons. Now these nucleons are simply the protons and the neutrons. So nucleon number is simply the sum of protons and neutrons in the nucleus of an atom. So the sum of protons and neutrons in the nucleus of an atom gives me the nucleon number. Nucleons is the collective name for protons and neutrons. So the nucleon number is the number of nucleons. What are nucleons? Protons and neutrons. So nucleon number is simply the sum of protons and neutrons in the nucleus of an atom. Then we said something about the mass of an atom. We said the mass of an atom, so the mass of an atom is concentrated within the small nucleus. So within the small nucleus, that's where the entire mass of an atom is concentrated. So whatever is found in the nucleus will give us the mass of that particular atom. So, but what are found in the nucleus? The protons and the neutrons. So if I count the protons and the neutrons, I'll get the mass of that particular atom. So in other words, the protons and the neutrons will give us something called the mass number. So mass number of an atom is simply the total number of protons and neutrons that are found in the nucleus of an atom. So mass number can be related to nucleon number simply because they're talking about one and the same thing. The mass of an atom is concentrated within the nucleus. So if I count whatever is in the nucleus, that will be the mass of that particular atom. So mass number is simply the total number of protons and neutrons in the nucleus of an atom. So total number of protons and neutrons in the nucleus of an atom, this is what we call the mass number. So mass number talks about what is found in the nucleus because the mass of an atom is concentrated within the nucleus. So whatever is in the nucleus will give us the mass of that particular atom. Now, for neutral atoms, what we should know is that the number of protons is equal to the number of electrons. So if an atom has 14 protons, then automatically the number of electrons in that particular atom is also 14 because that atom is neutral. So we mostly represent atoms by using chemical symbols. An example of an atom that I can represent here is sodium atom. Sodium atom is represented by this symbol. We have 23 here, we have 11 here when you look at your periodic table. This number, which is at the top, is the mass number of an atom. This is the mass number. This number, which is at the bottom, this is the proton number. When we say proton number, we're talking about the number of protons in that particular atom. So for example, in this case, when we count, we have 4 protons here, meaning the proton number of this atom is simply 4. So proton number is the number of protons in that particular atom. The proton number tells you the position of an atom on the periodic table. For this reason, the proton number is sometimes referred to as the atomic number because it tells us the position of an atom on the periodic table. So proton number, atomic number simply means one and the same thing. So the number of protons in an atom is the proton number, which tells you the position of an atom on the periodic table, atomic number. Then the mass number is how many protons and neutrons are within the nucleus of an atom. That is the mass number. So mass number is simply the sum of protons and neutrons. When you add the protons and the neutrons, you get the mass number here. So in this atom of sodium, we have 23 as the mass number. We have 11 as the proton number. What it means, protons in this particular atom, looking at this, we have 11 protons. Then this number tells us that when we add protons and neutrons, we are getting 23 because it's a mass number. So I can find out how many neutrons were added to these protons so that I can get 23. So this mass number is the sum of protons and neutrons. But I already know the number of protons, it's 11. So I can find the number of neutrons. So I'll subtract negative 11 on both sides. Subtract 11 on both sides, so these will go. So 23 minus 11, this is 12. So the number of neutrons in an atom of sodium is 12. What about the number of electrons? If an atom is neutral, we said the number of protons should be equal to the number of electrons. So for neutral atom, the number of protons and electrons must be the same. So an atom of sodium has a number of 11 electrons. Simply because we have 11 protons, it implies that we have 11 electrons in this particular atom. So another example, if I have this atom, an atom of magnesium, 24 there and 12 here. So this 12 is telling us that there are 12 protons in the nucleus of magnesium atom. Then this 24, which is the mass number, is telling us that, oh, when we add protons and neutrons, we are getting 24. Now, I can figure out how many neutrons were added to these protons because I know the number of protons. It's 12. So 12 plus n should give us 24. So n will be 24. This one will come there, minus 12. So n will be 12. So we have 12 neutrons. What about the number of electrons? We know that the number of electrons is simply the same as the number of protons. So electrons are also 12. So protons, 12. Electrons, 12. What else? Neutrons, 12. So this is an atom of magnesium. So in a nutshell, an atom has protons and neutrons in its nucleus. It has electrons in its energy levels or the shells. The protons and the neutrons collectively are called nucleons. So when I count the number of protons and neutrons, I get the nucleon number, which is also the mass number of that particular atom. The electrons are equal to the number of protons if at all the atom is neutral. Thank you for watching this video, and this is what we had for you. God bless you. Thank you.